Hello, in today's video, I'll be solving questions on the topic periodic table under IGCSE Chemistry. Before we delve into the questions, I want us to look at the color and state of the halogens at room temperature and pressure and in aqueous solutions. So I have created this table purposely for that. The color of fluorine at room temperature and pressure, that's RTP, is pale yellow. Chlorine is pale yellow green in color. Bromine is red brown. Iodine is gray black. That's the color of iodine at room temperature and pressure. And astatine is black. For the state, fluorine is a gas. So fluorine is a pale yellow gas. Chlorine is also a gas. Bromine is a liquid. So it is a red-brown liquid. Iodine is a solid. Astatine is a solid. And there is also one last one that I know we'll be talking about. That is tennessine. It is also a solid. That is the last halogen under astatine. When fluorine dissolves in water, we get a pale yellow solution. For chlorine, we get a pale yellow green solution. For fluorine and chlorine, when the solution is dilute, we get a colorless solution. When dilute, this will also be colorless when the solution is dilute. For bromine, we get an orange solution. So this is the color of bromine in aqueous solutions. For iodine, we get a brown solution. For astatine, extensive research has not been done on this. Although iodine is a solid, it can sublime into the gaseous state. And when iodine sublimes, the vapor is purple or violet. Also, all halide ions like fluoride, chloride, bromide, iodide, astatite, and tennessite are all colorless in aqueous solutions. It is the reason why when you have, for example, sodium chloride dissolved in water, the solution is colorless. When you have potassium fluoride dissolved in water, you see a colorless solution. And so when all halide salts are dissolved in water, because the halide salt contains the halide ions, the solution is colorless. So let's go into solving the questions now. The first question is question 2 of February-March 2024, paper 4-2. The elements in group 7 of the periodic table are known as halogens. Halogens can form halide ions. A. Identify the halogen with the lowest density at RTP. To solve this question, we need to look at the periodic table. And if you look at the halogens, you realize that fluorine is the one on top. And fluorine is the smallest of all of them. Fluorine has the smallest proton number, the smallest mass number, the smallest neutron number, compared to all the other halogens. And so it means that fluorine is the one with the least density. So this has to be fluorine. B. State the appearance of bromine at room temperature and pressure. So what we did over here, we saw that at room temperature and pressure, bromine is a red brown liquid. So you also have to add the liquid because color is part of appearance and the state is also part of appearance. C. Use the periodic table to give the symbol of the halogen with the highest atomic number. So let's look at the periodic table again. We can see that tennessine is the last element in group 7 or among the halogens. So it is the one with the highest atomic number. So since they are asking for the symbol, this has to be Ts. Deduce the number of occupied electron shells in an atom of this element, referring to tennessine. So the electron shells refers to the period number. So if you check here, you can see that this is period 1, this is period 2 here, period 3, 4, 5, 6, 7. So tennessine is in period 7, which means that it is going to have 7 electron shells. And so this has to be 7. D. Bromine molecules have covalent bonding. I. State what is meant by the term covalent bonding. In covalent bonding, non-metals come together to share electron pairs in order to attain a full atomal shell electronic configuration. So covalent bonding is the sharing of electron pairs between two non-metals to attain a full atomal shell electronic configuration. And once they attain a full atomal shell electronic configuration, the molecule becomes stable. II. Name one halide ion which bromine molecules can displace. For bromine to displace a halide ion, it means that bromine must be more reactive than that halide ion. If bromine is found above any halogen in the periodic table, it means that bromine is more reactive than that halogen. So it means that bromine will be more reactive than iodine, astatine, and tennessine, because halogens accept electrons to form negative ions, and the ability of the halogen to easily accept an electron makes it more reactive. So let's assume that this is the size of bromine and this is the size of the other halogens beneath bromine. We can see that as you go down the group, the sizes of the atoms are increasing. So the nucleus of these atoms are positively charged. So if there is an incoming electron, because the size of bromine is smaller, there is an easy attraction between the nucleus of bromine and the electron. And so that will make bromine easily accept electron than any other halogen beneath it. So looking at this one, the size is bigger. So the distance between the nucleus and the incoming electron is bigger. So it's not easy to really accept electron in the case of the bigger halogens compared to bromine. And so that makes bromine more reactive than any other halogen that falls beneath it in the periodic table. So bromine is more reactive than the halide ions of these three: iodide, astatide, tennesside. So in the exam, since they're asking for one, you can write just one of them. III. Explain why bromine can displace the halide ion in DII. So bromine is more reactive than iodine. It is the reason why it will displace the iodide ion. E. Name a halide compound which can be used to detect the presence of water. The only halide compound which is used to detect the presence of water is anhydrous cobalt 2 chloride. Anhydrous cobalt 2 chloride is blue in nature. When it comes into contact with water and becomes hydrated, it turns pink. Notice that in this question they said name, not the chemical formula, so you have to write the name. The next question is question 2 of May-June 2024, paper 4.1. We are supposed to complete this table. So for the number of protons of chlorine, it is 17. This is the proton number, and that is the mass number. Mass number is also the same as nucleon number. And number of neutrons can be found by subtracting the proton number from the mass number. So this is the mass number, this is the proton number. So when we do that, we get 20. The proton number for copper is 29. It is here. The number of electrons is 28 because the plus charge on the copper shows that it has lost one electron. So when copper is neutral, it's a neutral atom. So it means neutral means it has no charge on it. the number of electrons is the same as the number of protons, but it became charged by losing one electron. So it means that the number of electrons will reduce to 28. For this one, the proton number is 16. And when you look at the periodic table, you can see that sulfur is the 16th element. So this has to be sulfur. Number of electrons is more than the number of protons, which means that it has gained 2 more electrons. Once you gain 2 more electrons, you become negatively charged. So you have 2 minus. And the proton number is 16. The mass number will be gotten by adding the proton number to the number of neutrons. And when you do that, you get 33. The next question is question 5 of May-June 2024, paper 4-2. Sulfur is a group 6 elements. A sample of sulfur contains 2 isotopes, isotope 32 and isotope 34. Complete table 5.1 to show the number of protons and neutrons in one atom of each isotope of sulfur. So sulfur in the periodic table is the 16th element. So that means proton number is 16. So this is 16, 16. Number of neutrons is the mass number minus the proton number. The mass number is the one on top. And so for this one, 32 minus 16 gives us 16. And 34 minus 16 for this one gives us 18. The next question is question 2 of FEB-MAR 2023, paper 4-2. Lithium, sodium, and potassium are group 1 elements. Name the type of bonding in these elements. Now we know that group 1 elements, group 2 elements, group 3 elements, including transition metals, are metals. And so if lithium, sodium, and potassium are in group 1, it means they are metals. So the type of bonding in this element is metallic bonding. B. Sodium reacts with cold water to form hydrogen gas and a solution of a strong alkali. Alkali means a soluble base. So basically, this is going to be sodium hydroxide. State the test for hydrogen gas. So if you want to test for hydrogen gas, you have to bring a lighted splint or a glowing splint closer to the tip of the test tube that the hydrogen gas is being produced from. And when you do that, you are going to hear a squeaky pop sound. It's a very, very loud pop sound. And so that shows that it is hydrogen gas present. Suggest the pH of a solution of a strong alkali. So for group 1 methyl hydroxides, usually they are very, very strong bases. And so we usually write the pH as 14. So from 13 to 14 is fine, but usually Cambridge goes with 14. So to be on the safer side, let's go with 14. Name a substance which can be used to confirm the pH of a solution of a strong alkali. The only substance that can be used to check for pH of solutions is universal indicator. So the universal indicator is going to change color when you add it to a certain solution. And you can compare the color change to the color chart of the universal indicator, and it's going to tell you the pH of that particular solution. Write the symbol equation for the reaction between sodium and cold water. Include state symbols. So when group 1 metals and calcium react with cold water, calcium is in group 2. When they react with cold water, you only get a metal hydroxide. So in this case, sodium hydroxide, which is aqueous, plus hydrogen gas. So state symbol is gas. Now you can see that over here there are two, at the reactant side there are 2 hydrogen atoms, but at the product side we have 3. So the easiest way to balance this equation is to make the hydrogen on the product side even. So since there is 2 here, we put 2 here, and that will make hydrogen on the product side 4. Once we do that, we can see that oxygen has increased to 2 on the product side, but it is 1 on the reactant side. So we just have to put 2 here. And hydrogen has now increased to 4, which is the same 4 on the product side. And we can see that this balancing has also affected sodium. Sodium is 2 on the product side. It is 1 on the reactant side. So you have to add 2 to the sodium. Sodium is a metal, so the state symbol is solid. Water is the only liquid in chemical reactions. Sodium hydroxide, that's a base dissolved in water, so it's aqueous. Hydrogen is a gas, so we write G. C. Lithium has 2 naturally occurring types of atoms, lithium 6 and lithium 7. These 2 are isotopes. I. State the name given to atoms of the same element with different nucleon numbers. So these are atoms of the same element. We can see that lithium is the 3rd element, so the proton number is the same. The mass number, which is the same as the nucleon number, is different, and neutron number for these 2 isotopes will also be different. So we call this isotope. II. Complete table 2.1 to show the number of protons, neutrons, and electrons in the atom of an ion of lithium shown. So when you check the periodic table, lithium is the 3rd element, so proton number is 3. The neutron number for this is 3 because you subtract the proton number from the mass number, which is 6, and you get 3. The number of electrons, this is a neutral atom. For a neutral atom, the number of electrons is the same as the number of protons. So since proton is 3, electrons is also 3. For this one, the neutron number is 7 minus 3, and that is 4. It has lost 1 electron, so it means that the number of electrons will be 2. The next question is question 4 of FEB-MAR 2023, paper 4.2. C. Copper is a transition element. Some physical and chemical properties of transition elements are shown. So for the physical properties, we have high density, high strength. And for the chemical properties, we have transition metals form colored compounds. They have ions with variable oxidation numbers. I. State one other physical property of transition elements. So since transition elements are metals, they are expected to have high melting point. High melting point is typical of transition metals compared to group 1 metals. There are other physical properties like conduction of electricity, metals being sonorous, metals being lustrous, and all. But we can go for this. II. State one other chemical property of transition elements. So far, there are only 3 chemical properties of transition elements. Unique chemical properties of transition elements compared to group 1 metals. These are 2, and the last one is they can be used as catalysts. Example is the transition metal iron used in the Haber process. Then you also see vanadium in the contact process. You also see nickel, palladium, or platinum in the hydrogenation of alkenes or hydrogenation of oils to form margarine. The catalyst used in the catalytic converter, that is in the exhaust pipe of cars, like palladium, platinum, and rhodium. The next question is question 2 of May-June 2023, paper 4.1. 2. The symbol of the element in period 2 of the periodic table as shown. lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, and neon. Use the symbols of the elements in period 2 to answer the questions that follow. Each symbol may be used once, more than once, or not at all. Give the symbol of the elements that I makes up approximately 78% of clean dry air. So the percentage of nitrogen in clean dry air is 78%. II contains atoms with only 3 electrons in the outer shell. If you write the electronic configuration of all these elements, you should get 3 in the last shell, and boron gives us that. Because boron is the 5th element on the periodic table, and so if you write the electronic configuration, the first shell takes 2, the last shell takes 3. So that should be boron. III contains atoms with only 9 protons. On the periodic table, fluorine is the 9th element, and so it is the one with 9 protons. IV exists as graphite. Carbon is the only element that is found in graphite. V is an alkali metal. So alkali metal is referring to a group 1 metal, and lithium is the only group 1 metal over here, so Li. Vi only has an oxidation number of 0. It is only group 8 elements that have 0 oxidation number, and the only group 8 element here is neon. So it is only group 8 elements that cannot have any other oxidation number apart from 0. And also, due to the fact that noble gases or group 8 elements don't combine to form other compounds, there is no way their oxidation number will change. But these other elements, when they combine to form compounds, they are likely to have different oxidation numbers. The next question is question 2 of May-June 2023, paper 4-2. Question 2. Fluorine, chlorine, and bromine are in group 7 of the periodic table. A. State the name given to group 7 elements. Group 7 elements are called halogens. B. Explain why group 7 elements have similar chemical properties. So for you to have similar chemical properties, you should have the same number of electrons in your valence shell, because it is the valence shell electrons that you use in chemical reactions. And so for that matter, that will determine your chemical properties. And so if you have the same number of electrons in the valence shell, it means you should be having similar chemical properties. C. Complete table 2.1 to show the color and state at room temperature and pressure of some group 7 elements. So for fluorine, the state is gas. Fluorine is a gas at room temperature and pressure. The color of chlorine at room temperature and pressure is pale yellow green. And chlorine is a gas at room temperature and pressure. Color of bromine is red brown. It's red brown. Bromine is a liquid. D. Bromine has 2 naturally occurring isotopes, bromine 79 and bromine 81. I. State the term given to the numbers 79 and 81 in these isotopes of bromine. So these are the mass, or mass number is also called nucleon number. II. Complete table 2.2 to show the number of protons, neutrons, and electrons in the atom and ion of bromine shown. So proton number, when we check the periodic table, bromine is the 35th element. So it means the proton number is 35. So this is 35 and 35 for this. For the number of neutrons, we subtract the proton number from the mass numbers. And so for this is 44. The number of electrons is 35. It is the same as the number of protons because it is a neutral atom. When we come here, when you subtract the 35 from 81, you get the neutral number to be 46. Here it has gained one more electron. So we add 1 to the 35 and that will give us 36. And the number of electrons is 36. The next question is question 2 of May-June 2023, paper 4-3. Question 2A. The symbols of the elements in period 3 of the periodic table are shown. Sodium, magnesium, aluminium, silicon, phosphorus, sulfur, chlorine, argon. Use the symbols of the elements in paper 3 to answer the questions that follow. Each symbol may be used once, more than once, or not at all. Give the symbol of the element that I is present in purified bauxite. The ore of aluminium is bauxite. II contains atoms with a full outer shell of electrons. All group 8 elements or the noble gases have a full outer shell of electrons. So this has to be argon. III is used to kill microbes in water treatment. It is chlorine that is used to sterilize or kill microbes. IV forms an amphoteric oxide. When aluminium reacts with oxygen, it gives you aluminium oxide, Al2O3. And this is an amphoteric oxide because it can react with both acids and bases. That makes it amphoteric. V forms an oxide which causes acid rain. This has to be sulfur because when sulfur is roasted in air, it produces sulfur dioxide, SO2. And SO2 can react with water to give H2SO3, which is a weak solution of acid. The same way, the SO2 in air can also react with oxygen to give SO3, and SO3, once it is produced, will also react with water to give H2SO4, which is also a strong acid. So this will be formed when SO3 reacts with water. And this can rain down as acid rain. Vi has an oxidation number of -1 when it forms a compound with hydrogen. This has to be chlorine. So chlorine reacting with hydrogen will give you ACl. The oxidation number of hydrogen here is +1 and that of chlorine is -1. So this has to be chlorine. The next question is question 3 of October-November 2023, paper 4-1. B. The reactivity of group 7 elements can be investigated experimentally. A student bubbles chlorine gas into a test tube containing aqueous potassium bromide. I. Describe the color change seen in the test tube. So in this reaction, chlorine gas was bubbled through a solution of potassium bromide. Chlorine is on top of bromine in the periodic table. It means chlorine is more reactive than bromine. So chlorine can displace bromine in a displacement reaction. So we get potassium chloride. So 2 moles of that plus Br2. And so we just balance that. Now, potassium bromide is colorless. Remember, we said when you have halide ions in solution, it's colorless. So the solution at the start was colorless before chlorine was bubbled through it to form potassium chloride and bromine. Again, this one will also be colorless, but bromine will be orange in solution. So we go from colorless to orange. II. Complete the ionic equation for this reaction. Include state symbols. So for the ionic equation, we have chlorine, and chlorine is a gas. When you react it with the bromide ion, so For the ionic equation, we have to remove spectator ions. So in writing the ionic equation, we separate the ionic compound, which is potassium bromide, into ions. So that would be 2K plus 2Br minus, giving 2K plus 2Cl minus plus Br2. You can see that K plus is on both sides of the equation. So that is the spectator ion. So we need to cancel K plus 2K plus out of this equation. That will give us the ionic equation. And if you look at this, you can see that that's 2 moles. It's aqueous. Then we have 2Cl minus, which is also aqueous, plus Br2. And this must also be aqueous. III. The reactivity trend seen in Cl, Br, and I applies to all elements in group 7. Use the periodic table to identify the group 7 element which cannot displace any other group 7 elements. So if you look at the periodic table, it is tennessine, that is the last element in group 7. So it is the least reactive of all the halogens. So there is no way tennessine can displace any halogen in a displacement reaction, because all of them are more reactive than tennessine. The next question is question 1 of October-November 2023, paper 4-2. Question 1. Table 1.1 gives the electronic configurations of some atoms and ions A to G. So this table 1.1, these are the atoms or ions, and these are their electronic configurations. Answer the following questions about A to G. Each letter may be used once, more than once, or not at all. State which of the atoms or ions A to G could be A noble gas atom. Noble gases are found in group 8. So it means that the valence electron must be 8. If you look at B, it is the one that has the last or the valence electron as 8. So it means that B is a noble gas. B, an atom of an element in group 6. So it means that the last electron must have, the last shell must have 6 electrons in it. And F gives us 6 electrons in the valence shell. C, an atom with an atomic number of 14. So if you want to get the atomic number, just add all these numbers, all the electrons together, and you are going to get the atomic number. So if you add this, you get 2 plus 8 plus 4, that gives us 14. So this must be D. D, atoms from the same group. The number of valence electrons shows the group number. So it means that for you to be in the same group, you must have same number of electrons in the valence shell. And if you look at A and E, they both have 5 electrons in the valence shell. So this must be A and E. E, a halogen atom. So a halogen atom means it is in group 7. So it means that the last electron must be 7, and that will show that it is a group 7 element. And G is the atom with 7 electrons in the valence shell. F, an atom of an element which is a good conductor of electricity. So this must be a metal between group 1 to 3, including the transition metals. So if you look through, you can see that it is C, which is in group 2 because of the valence electron. So C is the only metal there, and so that must be the one. G, a stable ion of group 5 elements. So the ion is of a group 5 element. It means that initially it was having 5 electrons in the valence shell. and now it is forming an ion. It means that group 5 elements are non-metals, so they have to gain electrons. And so it is forming a stable ion. That means that the outermost shell is now fully filled. So which means that it is actually gaining 3 more electrons to form 8. So we must see 8 electrons in the outermost shell after the atom has gained 3 more. And B is the only one that gives us 8 electrons in the outermost shell. So this has to be B. H, an atom that forms an ion with a -2 charge. So this must be in group 6 or group 6 of the periodic table, because they are the only ones that can gain 2 more electrons to be fully filled. And if you check, it is F. F has 6 electrons in the outermost shell. It means it can gain 2 more electrons to form an ion with a -2 charge. The next question is question 2 of October-November 2023, paper 4-2. Question 2. Cobalt and copper are transition elements. A. Copper has 2 naturally occurring isotopes, copper 63 and copper 65. Cobalt has only 1 naturally occurring isotope, cobalt 59. I. Complete table 2.1 to show the number of protons, neutrons, and electrons in the cobalt 59 atom and the copper 62 plus ion. So for cobalt 59, the proton number, as can be seen from the periodic table, is 27. Copper is 29. So we have this as 27 and copper as 29. For the number of neutrons of cobalt, we need to subtract the proton number from the mass number. And when we do that, we get 32. This is a neutral atom. There is no charge on it. So it means the number of protons is the same as the number of electrons. So this has to be 27 as well. For the neutral number of this, if you subtract the proton number from the mass number, that is 65 minus 29, we get 36. For the number of electrons, the +2 charge on copper means it has lost 2 electrons. And so initially the number of electrons was 29 when it was a neutral atom. So if it has lost 2 electrons to form an ion, it means that the number of electrons now is 27. The last question is question 2 of October-November 2023, paper 4-3. Question 2. Table 2.1 gives information about particles A, B, C, D, E, and F. So these are the particles shown in table 2.1. The number of electrons, number of neutrons, and number of protons. A. Give the letters of all the particles which are atoms. So for atoms, it means number of electrons must be the same as number of protons. That is how you know that it is an atom. If you look through, you can see this and this is the same. We can also see this and this also being the same. We can also see F, the proton number and the number of neutrons being the same. So this is going to be A, B, and F. II. Ions with a charge of -2. So for this one, it means that the atom has gained 2 more electrons. So we are supposed to see the number of protons 2 less than the number of electrons, or the number of electrons must be 2 more than the number of protons. And when we look through, we can see that for D, the number of electrons is 18 and protons is 16, which means D has 2 more electrons than protons. III, cations. So for cations, the proton number must be more than the number of electrons. And when we look through this list, we can see that for C, the number of protons is 3 more than the number of electrons. So it means that our cation in this case is going to be C. That is the only cation there. B, state the atomic number of A. Atomic number is the same as proton number, and the proton number of A is 5. So it means you have to write 5 on this one. C, determine the number of nucleons in D. The number of nucleons is the same as mass number. And to get the mass number, you add the number of protons to the number of neutrons. So for D, when we add 17 to 16, we get 33. D, state the electronic configuration of D. We write the electronic configuration by using the number of electrons. So D has 18 electrons. So it means that the electronic configuration is going to be 288. E, state the group number of F. We can deduce the group number of F by looking at the valence electron of F. F has 15 electrons. So it means that when we write the electronic configuration, we get 285. The valence electron is 5. It means that F is in group 5. F, states the period of B. For the period of B, we can look at the number of electron shells, because number of electron shells determines the period number. And the number of electrons in B is 10, so it means electronic configuration is 28. So that would mean 2 shells. For that matter, B is in period 2. Thank you for watching. See you again in the next tutorial. Please subscribe to this channel.